So this is the game I made for Unity for our Development 105 programming project. It's a simple 2D survival game. All you gotta do is dodge the blocks. You can double jump in it, you can move, and if you hit any of them you will die as per scene, or if you go off the screen you will also die. So for the main camera angle we have for the game, it is on 5.7, just to give it a nice, almost a nice little panel one, so that they can't go too far out and it just keeps it all looking nice. Then on the camera there's also the post-processing, which I have some fog on, a bit of anti-aliasing, a bit of motion blur on the enemies, just so when they're coming down, it makes it look a little bit cooler. You then have some fogging and it just boxes in the view, and I like the effect it gives to it, so I thought I would go there. For the character, you have a rigid body 2, so he has some physics applied. Throws position Y, so I don't want him to go too far. You have a box collider, so that he will collide with anything. There's also the player movement script, but I'll get to that soon. You also have a unnoted child of him. You have the ground check. This is so that when it comes into contact with any of these platforms which have the layer ground added to them, it will tell the player that is the ground and will actually reset their jumps. The code, I'll get to that in a bit. The platforms have a box collider, but just on default settings. You then have the spawn manager. It has the spawn script and a prefab falling block, which has the falling block script and a 2D collider, so that when the player hits it, it does register, and it is also a trigger for the player's death. There's the event canvas, which in the canvas you have the event canvas, and that has the text, even though it just says new text there in game. As you saw, it is a timer to show the player how long they've survived. On the script, start with the timer. You have the timer and the public text for the timer text, which will be linked to the canvas over there. The public float speed is just 1, so it goes up 1 by 1, and it's not going to go up too fast. You have the void start. The only part we have is the start of the timer to start it, because we don't want it starting over and over. You have the start time equals delta time times time. Then you have the string, which helps calculate the minutes. You also have the string for seconds with start time, like that. Then you have the timer.text equals minutes plus over, showing the timer there for the player to see. Falling blocks, there's not a lot. You have the speed, which I can change as I will. It is currently set to 7. This translates to the speed of them by the delta time, giving it so they fall at a certain pace and not randomly. On the spawner, I have a few public parts, as can be seen, and a few floats, and a vector 2 for the screen size world units. This is one I have defined, and I will place into quite a few parts, as you can be seen down here. So the public vector here is spawn size min max. This is the public vector which will be used to define how big and small the players can be. The public float for their angle can be so that they will come into an angle, not falling just straight down. And then here you have the spawner, which also uses this screen half size world units to stop the enemies spawning off the screen and out of the player. So it uses the camera main aspect and then the camera auth size to keep it all within the screen that the player can see. You now have spawn, and then down here you've got spawn.spawn time, and if the spawn time is greater than the next spawn time, spawn in the next enemy. And there is seconds between spawn, which I currently have set to 1, but can be changed with the in-game. The spawn angle equals random range, so that they would spawn at a random angle rather than all coming in at one area. We also have spawn size on a random range, because I don't want them all spawning in one size, just give it a bit of variety, make it a little harder for the player to survive. So you have spawn position, and this will help determine the range on the screen using the world half size. +5, and this is there to stop them from spawning inside the screen and partly clipping into it. This will make them spawn just above the screen and then fall in, so the player can't see them if they're going at an angle. Then you have the object new block using instantiate, and this calls the falling block prefab and the spawn location. And then you control a ruler with a vector 3 to forward times the spawn angle. And this means that when they spawn in, they will fall in the direction that they are angled rather than just being half sideways as they fall down. You then have the new block.times transform, local scale, vector 1 to get them all to spawn in at a different size. Then onto the player movements, we have public float for jump force. So this is going to hold our jump so that and that's for how hard and high the player jumps. You then have the speed, which is currently set on 5. You also have the private float for movement, which is currently set to 1, but does play in the main game. You also have private rigid body 2D, which is calling through the rigid body. You also have the float half screen, which is needed because later on it will show just down here that it stops the player from going off the screen and they will come back through to the other side. So we have the private ball here, which is facing true, which is linked to down here a bit further. I'll get to that in a minute then. This is all for the ground check to see if the player is on the ground, and it will tie into a small object just under the player, as I showed earlier. The private int extra jumps in the public value extra jump value is needed. So you have the extra jumps equals extra jumps value. The extra jump value is currently set at 1, so that the extra jumps will be called through. You have the rigid body 2D, getting the component rigid body so that the player has some physics tied to them. The screen half width units equals the camera aspect times the camera main orthodox size, and this is to stop the player from going outside of the playable area. So when it sees the end of the side, it will hit it and it will spawn the player to the other side. And then the void updates, we have the is ground, we'll set the 2D physics little circle just underneath the player, which will check the radius and check what is ground. If anything with the ground tag will class as ground. Then you have the movement put in access raw horizontal using Unity's inbuilt horizontal X and Y. This is then classed as the movement controls for the player, so the player can move left and right. You then have the rigid body velocity and the vector 2 movement times speed of rigid body, and this is just to keep the player moving with the physics applied to it. So, and this is the if statement I put for the extra jumps. So if the is ground is true, the player gets extra jumps as 1. And then you have the if, and then you have the jump code. So if the player presses spacebar, the player will jump and they will return to 1 jump. And then the RB velocity and the jump force, timesing it together so that the player gets the certain amount of jump. And then you have the else. If the player is pressing space and the extra jumps equals 0, is ground is true, it resets the jump. Then you have, this is the code which shows if the player is going off the screen. So transform position times x is less than the screen half width transform position new vector to the screen half width transform y. If the, and this is the else, if the position x is greater than the screen half width units, it will put the player, the vector 2, the screen half width in world units and transform dot position to y. So I'll put this player from the right side of the screen to the left side of the screen, and then the left side of the screen to the right side of the screen, either way. This was to stop the player from always facing in one direction when they were moving it. So if the player is facing right equals false and movement is greater than 0, it will flip the player around. Else, if the player is facing right and the movement is greater and the play is true and the movement is greater or less than 0, it will flip the other way. So this enables the player to be looking in whichever direction he or she is moving. And it's just a little more of the code for it. So facing right equals facing right. Then vector scaler, which transforms the local scale so that the player doesn't change too much when they turn around. And then you have the last bit, void on def trigger into 2D collider. It's the collider I need. If the trigger collider.tag, which is put onto any falling blocks, destroy the game object, end the timer on it, and quit the animation.